From California's most significant construction fiasco to China's massive demolition of unused high-rises, these are some of the priciest construction blunders in history. Are you aware of any other notable construction failures? Share them with us in the comments below. Number 1. The Harmon Hotel Las Vegas's city center is a massive urban complex located at the heart of the Las Vegas Strip. Announced in November 2004, it was envisioned as a luxurious living space featuring residential condominiums, a retail mall, and all the essential amenities for everyday life. A centerpiece of this ambitious project was the Harmon Hotel, a 137-meter-tall mixed-use high-rise combining hotel accommodations and residential units, complete with a rooftop pool offering stunning views of the Strip. Construction on the Harmon began in 2007, with initial costs estimated at $275 million. However, the project was only partially completed before being permanently halted. In 2008, inspectors uncovered serious structural flaws in the building. The steel reinforcements intended to support the planned 49 floors had been improperly installed, forcing construction to stop after the 28th floor. As a result, residential units were eliminated from the plans, requiring refunds for buyers who had already made purchases. This redesign caused further delays and construction eventually ceased altogether. MGM, the building's owner, wrapped the Harmon in reflective glass and repurposed it as advertising space. In 2011, it was revealed that the Harmon was structurally unsafe and would likely collapse in the event of an earthquake. In response, MGM decided to demolish the building. Due to the proximity of nearby structures, traditional implosion wasn't an option, and the high-rise was dismantled floor by floor. The dismantling process began in June 2014 and was completed by 2015. The demolition alone cost approximately $170 million, bringing the total loss on the Harmon to over $450 million. The building was never opened to the public and became a costly reminder of one of the most significant construction failures in Las Vegas history. Number 2. Okalo 3 Nuclear Power Plant. The Okalo 3 nuclear power plant highlights the challenges of expanding nuclear power infrastructure. Currently, over 30 countries rely on nuclear energy to meet electricity demands. In Finland, nuclear power accounts for about 30% of electricity production, but in 2005, the Finnish government decided this wasn't sufficient to reduce coal dependency. Plans were set to construct a modern and highly efficient third reactor at the Olkiluoto nuclear power plant in Ryugyong, which would boost Finland's nuclear power output by nearly 60%. The first 2 reactors at the site, operational since the 1980s, had performed reliably. Construction on the third reactor began in 2005, marking the first nuclear reactor built by a Western nation in 15 years. However, the project faced delays from the very beginning. Although TVO, the company behind the Olkiluoto plant, initially promised the reactor would be operational by 2010, it remains under construction today. While the main buildings were completed relatively early, the installation of nuclear components took years, hindered by business disputes, supply chain disruptions, and scheduling setbacks. These challenges pushed the project 12 years behind schedule and $8 billion over its initial budget. Experts point to the long hiatus in nuclear reactor construction as a significant factor. The 15-year gap meant many experienced builders had left the industry, leaving contractors ill-prepared for the exacting standards required for nuclear safety. Early on, the concrete foundation was found to be irregular and had to be redone. Contractors also failed to properly forge some reactor components, and welders weren't adequately trained before construction began. Administrative hurdles further complicated progress, with extensive documentation and licensing requirements taking years to resolve. TVO now anticipates that Olkiluoto 3 will begin regular power generation by February 2022. Initially estimated at $3 billion, the project's cost has ballooned to $11 billion, nearly 4 times the original budget, due to the prolonged delays and complications. This endeavor serves as a costly lesson in the challenges of reviving nuclear reactor construction. Number 3. Hallandsås rail tunnel. In 1975, Sweden's rail system faced significant challenges as sections of the West Coast Line struggled to handle increasing train traffic. To address this issue, a large-scale project was launched to upgrade the entire line to double track. A critical component of this project was upgrading the single-track railway through the Hallandsås Ridge, a major bottleneck for trains traveling between Gothenburg, Sweden, and Copenhagen, Denmark. Construction of the Hallandsås Tunnel began in 1992 with an initial goal of completion within 3 years. However, the project encountered major obstacles almost immediately. Groundwater seeped from the rock in far greater volumes than anticipated. The soft rock made large-scale drilling difficult, breaking the first drill used. Traditional drilling methods only worsened the water leakage, compounding the challenges. These setbacks forced the original contractor into bankruptcy, leading to a handover of the project to a new team. Unfortunately, the new contractors also struggled. During construction, they used a toxic sealing compound without proper safety measures, which caused environmental damage. Livestock and fish in the area began dying, and workers on the project fell ill. These issues led to criminal charges against the company and another halt in construction by 1997. At that point, only 3 kilometers of the planned 8-kilometer tunnel had been completed. After an 8-year pause, construction resumed with new drilling equipment and improved techniques, making progress more manageable. However, delays persisted in areas with weaker bedrock, as extra precautions were needed to safely bore through these sections. The Hallandsås Tunnel was finally completed in 2015, 23 years after the project began. Initially projected to cost 1 billion Swedish kroner, the final cost ballooned to approximately 10.5 billion kroner, 10 times the original estimate. This project remains one of Sweden's most infamous examples of construction delays and cost overruns. Number 4, Eastern Span replacement of the San Francisco-Oakland Bay Bridge. The Eastern Span replacement of the San Francisco-Oakland Bay Bridge is one of California's most notable infrastructure projects, with a history of delays, design challenges, and soaring costs. Each year, more than 27 million vehicles cross the 10-lane San Francisco Bay Bridge, connecting Yerba Buena Island and Oakland over a span of 3.5 kilometers. Given the bridge's vital role, safety is paramount. However, the Loma Prieta earthquake on October 17, 1989 exposed the original bridge's vulnerabilities when the 6.9 magnitude quake caused part of it to collapse. City officials recognized the urgent need to address these structural concerns. Retrofitting and repairing the damage was deemed too costly, so they opted to replace the Eastern Span entirely. A design contest was held, and after a decade of deliberation, a self-anchored bridge design was chosen for its aesthetic appeal. Unfortunately, the complexity of this design led to numerous problems and skyrocketing expenses. Stability rods frequently broke, necessitating repairs or complete refabrication. Guardrails chosen over barriers proved prone to corrosion over time. Misaligned deck sections increased the risk of earthquake-related failures, while subpar welding quality prompted extensive investigations and costly fixes. Construction of the new Eastern Span took 11 years, making it California's most expensive infrastructure project to date, though the state's high-speed rail project might eventually surpass it. Initially estimated to cost just over $1 billion, the total expense had reached approximately $7 billion by 2019, 7 times the original bid. The final cost remains uncertain, as the project included numerous design and construction challenges, highlighting the difficulties of large-scale infrastructure projects in earthquake-prone areas.